Okay, awesome. Cool. So we have Max. I will leave you to
Sure. Thank you very much. Please take a seat. If you cannot stand anymore, there's some chairs left. Otherwise, I'm very welcome you here in our beautiful Solar office, which stands for, I don't know, something about social and networking and laboratory at Reply. Yeah, it's myself. You can see it's quite similar. Maybe this guy looks a little bit better because the picture was done by my wife with a professional camera. Nevertheless, I'm founder of Liquid Reply, so we're a consulting company specialized in all of the Kubernetes stuff and containers and FinOps and whatsoever. Having hard times to sometimes explain it to the big customers how the new world works, but this is part of our fun. And all the other stuff is getting sometimes a little bit more ridiculous. So I'm a CNCF ambassador, co-chair for the CNCF Tech Environmental Sustainability, something which I started almost a year ago. Meanwhile, it's getting quite big. I'm also advisory board member at the Linux Foundation Europe and a few other stuff. But most importantly, I'm here as Max. Yeah, as I said, we're a Kubernetes and cloud native company. And maybe you wonder why there's always like Reply, and here's also Reply. It's like a big network. Imagine it as a shopping mall. So you go to the shopping mall and you maybe need some sneakers, so you go to the sneaker store, and then you go to the cafe to get a coffee and so on. The same as with Reply. Everyone is specialized in something. Sometimes it's maybe fields related, but quite often every one of us is very much specialized in the one or other thing. So today we're going to talk, or I'm going to talk a little bit about WebAssembly, or also called WASM, what it is about, why it is even relevant nowadays, how and what is the current status. This is sometimes a little bit tricky because practically every day something happens in this space, so it's like change every day. And then because we are also a little bit oriented in the developer experience, we take a look how you can get started as a developer into this and try to learn and understand a little bit more about WebAssembly and WASM. So Solomon Hykes, someone maybe of you know him. This is one of the guys who have invented practically Docker. And he says like, well, if in 2008 there would exist already the WebAssembly specification, and someone would have told me that WebAssembly is the next big thing, I would never have need to invent Docker. So he basically acknowledged that all the cool thing which he have done and the change which he brought to the IT world could be also to someone else gratitude if it would be invented a little bit earlier than the containers itself. But what is WebAssembly? Because this web part of WebAssembly is sometimes a little bit misleading. Originally, WebAssembly was really developed just for running in the web in your browser. So you have some applications out there, like Figma or like Google Meet, which is running in a container environment, which is in the end actually a WASM module. And what is so cool in it is that everything within this container, and we come to it a little bit more close, what does it really mean, is secure by default. You do not have any access rights. You cannot do any root stuff. Theoretically, if you would spin up the container without anything else, there would be you could not look at it. Nothing happens. It's just like runs, execute, done. Because you need to be very precise in what it is allowed to be done as a WebAssembly. And WASM itself is in the end like a binary format, something which you get out if you wrote your code. You get this together. You can define it as a container if you want to. This is relevant if you want to put it in Kubernetes, for example. You can store it more or less everywhere, doesn't matter. And what is so sweet and nice about it is that it's very small. So typically, if we have a fully functional WebAssembly container, which we throw somewhere, if it is big as a megabyte, it's already big. Like this is a fat one. You have some environments which are getting a little bit more bigger, 3 megabytes, 4 megabytes, whatsoever. But as you may know, typically in the big enterprises, a container itself is often like gigabytes big. Huge, right? Even if you want to use something lean and sexy like Gitpod, but you start installing a lot of stuff. You want to have, I don't know, I mean, you support out of the box Rust and Go, so the heavy child is out of the door. But if you want to build something else into it, you need to download gigabytes of data, and they're all in this container running, so it's getting always very, very large. So with WebAssembly, this problem solved because you do not have any operating system in it. This layer is gone, all the other packages is gone, so this world of problems is out of the door. It's extremely fast. If you think serverless, for example, is fast, WebAssembly can do it in 1/5 of the time when we're talking about startup time. So practically your program, your software never needs to run, because only when the request hits your server, it just fires it up, answers it, and goes sleep again. Very, very nice. Universal and reusable. I do not want to go too much on it, because this is also what the promise of a container is. Because with WebAssembly, it's just depending on which runtime you have. If your runtime can run anywhere, and there can be multiple runtimes, your WASM module can be also executed anywhere. So if you have a very, very specific architecture, processor architecture, right? Looking into the RISC-V community, which do some very cool development recently, so whatever comes out of there, if you build for this a specific WASM runtime, you can just execute your WASM module as you could do it with your ARM or whatever else you have executed before. So how we see it is that WebAssembly is somewhere in this real middle part between safetiness, portability, it's fast, and it's polyglot. Yet it supports around 30, 35-ish programming language, so not all of the crazy stuff out there. Maybe you will have unluck when we talk about brainfuck, or I don't know which programming language you prefer. But it's sitting very much in the middle of all of this stuff. And the funny thing is, like, I would say 5, 6, 7 years ago, you would more or less come out with the same slide and just have here this little Docker weight in the middle. But it's got like faster, leaner, more secure, and so on and so forth. Obviously, it also has some downsides, but we come to this later. And where we can run it, well, there's a lot of stuff going on. Figma, we talked about it, is one of the most famous examples in this field, because they practically run the whole design studio that designs software in a browser in this little WebAssembly module. Very awesome. You can run it as a plugin system. If you want to configure an envoy proxy, you can write your rules. There will be basically built as a WASM module and injected into the envoy proxy, and just manipulates everything what needs to be done. We have sandbox environments like Firefox, for example, where you can prevent that if you plug in a new whatever nice random software from the store, that it cannot do anything harmful and just lives within the browser. We see also recently that we have in the blockchain environment a lot of this development coming up, for obvious reason, because you do not want to run somewhere when you have a distributed system somewhere on the globe where you do not have access onto the machine and you actually do not know who's running it. It would be not the best idea to have a container running with the operating system. So if we strip this down, nice use case for also blockchain. But last but not least, why we are so much interested in it is for containerization and also for serverless platform. And about this both categories, I would like to go a little bit more deeper with you to give a short introduction. And this is actually a slide which we have stolen by Liam Randall from WASM Cloud. But I actually like it very much, because we are currently somewhere moving here, and we help customers to move there and get their containers running and understand how to build more secure container. And I don't know how many hundreds of hours we spend already on hardening software, on hardening infrastructure. It's cool, it's keep us busy. It's also good to have every morning fresh sandwiches on the table, basically. But it's ridiculous because it's a repetitive task, which we do with every customer all the time, continuously, and actually nothing changes. It's always the same principles which we apply. So going for WebAssembly, we still have to do most of the things, but if you think about the application, I fully can turn off my brain in this direction. I can think like, okay, it's built in this module. The only thing which I have to guarantee is somehow network access, which is one of the biggest downside yet at WebAssembly. Network connection is a very big challenge. And we was like, well, Max, what does it help me to run an application somewhere if I do not can connect to it? Well, security first. But there are ways, for example, you put just the Envoy proxy as a sidecar, and tada, your problem is solved. So there are ways to go around this and to enable this network connection. Nevertheless, we believe that this is a very interesting direction where we also, you can see it already, you have WASM days around KubeCon, for example. The investments around the whole WASM-oriented companies are growing and increasingly getting more and more speed. So I would bet on this horse a little bit. I typically would talk about Krustlet, but there's a problem. Is that the space is so fast and no one maintains this at the moment. It's a very nice one. It's actually very cool written. Lean, fast, it makes fun, it's easy to install, but no one maintains it because, as I said, we have on the one hand side the problem with the network connectivity. As long as this is not solved in the WebAssembly specification, the Krustlet community doesn't want to provide any answer to this question. That's why this development is stale. The other downside on it is it replaces my complete runtime. This means that either I have a Kubernetes cluster, or at least a node group, which runs only Krustlet, or I have a node group or complete cluster which runs only typical containers. Not something which we always want to have. So there's another cool direction, which is called WASM Edge. And WASM Edge is living beside your cluster as a different runtime. As you may know, you can install and have as much runtimes as you want on a node. It doesn't make sense to have like Docker and containerd and something else running simultaneously. But this functionality helps us that you can install WASM Edge as your container runtime under Kubernetes, and you're good to go already to just get the thing started for deploying a WASM application somewhere. The only little downside, and we come to this later also, with WASM Edge is sometimes it's a little bit confusing because it can also run standalone. So you can deploy this everywhere, wherever you want, doesn't matter. Theoretically on your phone, theoretically on your robot, or I don't know, your NAS device, doesn't matter. And it can execute everywhere the same application, which is actually quite cool, but sometimes confusing because it sounds like the big solution to everything. And well, we know that big solution for everything, it's promising too much, and then people get a little bit hesitated and hold themselves back. However, as promised before, you can just in container. This is like a Docker file. This is a Docker file, you build it from scratch. You add your WASM module and you execute it. And that's it. This is how you get your container or your WASM module in the container and get up and running. The only thing is that you have to give a special annotation to it. And for this, you need, for example, the builder tool. Meanwhile, you also can do it with Docker, but in Docker, it's in a beta status. And this is like, I would not say battle-proofed, but it's very stable and it's also very repetitive in rebuild this same approach. The other cool thing is when you use this approach, you can utilize the same environment like until now. I do not need to think about, okay, I need yet another artifact store or another repository for all this stuff. I can throw it into the same stuff like before. You just have a different tag, that's it. And it can live in the same Kubernetes universe, which is also awesome because I do not need to rebuild all the stuff which I have so far, like storage interfaces, network, security. Security is in this case a little bit ridiculous, but all the stuff around it I can utilize. So from all these tools and the short summary, WASM Edge itself is like quite interesting to get started. If you really would like to put it into your backend system and want to prove it a little bit and throw a couple of applications on top and load it a little bit, with this one you cannot get wrong in any of these cases. And the only really big downside, but this applies to all WebAssembly tools and environments, is as a software developer, you have a very hard time. Because with this one, you spend more time on trying to find out what is wrong because you do not get any information from your application. Whatever you do wrong, there's just like random numbers and strings and whatsoever. Try to find out. So it's sometimes a little bit unfunny to debug your WebAssembly application. But For me, as an infrastructure guy, I luckily don't care. The other cool approach would be WASM Cloud. And these are actually the guys where I steal the graphic before. WASM Cloud is coming from a totally different perspective. And they're thinking about this whole topic like, well, we focus so much in building observability. We need to provision databases. We need to manage databases. We need to run all the backup and storage and whatsoever. So we spend so much time with all this unnecessary stuff. Yes, it's needed for the application, but actually I want to focus on building functionalities. You want to write one function, but you need to spin up a new database. You think about caching. Okay, fine. I build a couple of other functionalities. Suddenly I need a messaging system, whatsoever. So they get very much cluttered about it. And what WASM Cloud is doing differently, it's like you can, again, put the WASM Cloud runtime wherever you want. It can even run in Kubernetes. It can run on your VM, bare metal, all around the globe. And you can connect it through something called Lattice. It's in the end a NUTS message streaming server, which is connecting up. And you have two more other relevant parts. The one thing is the actor. This is actually where your application is living in. And then you have the capability provider. And as the name tells you, the capability provider solves for you, for example, networking. Because, as I said, with WASM, you have a little problem with the network connection. So there's a provider for handling HTTP traffic, for example. There's a provider for connecting to caches. There's a provider for connecting to databases. So you can just use these providers. You don't need to worry about anything else. They're running beside your application, and you're good to go. Now, why they have decided for this approach is like they want to think it differently. Your application is not running in one dedicated data center anymore. Somehow we're always stuck with this idea like, oh, I develop something, I need to put it on the server, and there it's running. And then, like, at least in Germany, there's this typical behavior where someone's like, okay, where is it? Frankfurt? Nice. Which village of Frankfurt? Langgöns? Or more like in the east part, direction of Fulda? I mean, it's like a couple of 100 kilometers difference, but hey. WASM Cloud tries to forget about this one. It's running somewhere, wherever else it fits for you. And as soon as something happens, like you try to get your mobile connection and then something breaks, the Lattice just will direct you to another node. And sure, you get this also if you build your own Kubernetes cluster, or typically you use your load balancer and you have it running high availability somewhere else. All the infrastructure takes care about it. But you have to take care also about the infrastructure. And with WASM Cloud, you only big things and stuff around it. You need to take care only about WASM Cloud because it handles everything else. At least that's the promise. I mean, obviously, you still need to put it somewhere on the server. You obviously still need to connect somewhere the network. Sure, I'm with you. But you can ignore everything else. Talking about cloud provider, you don't need to think that much about the security groups. You don't need to think that much about load balancing, API gateways, and whatsoever. You have it just somewhere running. So this approach overall is very cool. Has just a couple of downsides. First, you can just run Go and Rust. Go is awesome. Rust is even more awesome, but the learning curve was so hard that not everyone could use it at the moment. And you build an application with only WASM Cloud in the mind, because you need to rely on the connection, you need to rely on Lattice, and you need to rely on the provider which you get. If there's a provider missing, you have to develop the provider by yourself. Obviously, the community would be very, very grateful about this. But there's a lot of work which you can put into. And this is a very young project. Unfortunately, I think in the next weeks, there will be released version 1. So maybe we need to delete this like very young and just keep it as a young project. So what would be the dev-friendly approach for going into the world of WASM? Because we have learned so far, okay, you need to put somewhere some runtime under something. Either it's a Kubernetes or maybe it's on a bare metal server, whatsoever. Need a couple of hours. I mean, most of us have fun with this, but maybe if you just really want to test something, it's not the most convenient thing? Or do I want to build a completely new kind of cloud provider thingy? Also so much work to do. So what is the easier approach for it? The first thing is KWASM. This is not a complete product. This is actually, it's nothing. It's just an operator which my team has written. And they did a very fantastic job because it's the most dumbest, most stupidest approach on getting WASM done. But the cool thing is it runs everywhere. Kind, microcates, AKS, EKS if you have Ubuntu under it, Google Cloud, it doesn't matter. You just need to deploy shortly KWASM, and then you're good to go to also throw your WASM module into it. And you're very, very satisfied with it. I always undersell it a little bit. Our lead engineer for this, it's the most easiest way you can do this. You need to emphasize it. Big underlining, most easiest way to do it. And alternatively, we can talk a little about Fermion. Fermion is, I would say, growing very fast recently from the well-known environment. Because what Fermion does is provides, on the one hand side, a development framework, an SDK called Spin, where you can getting very fast up and running with writing your application. And you can also immediately deploy from your SDK towards Fermion Cloud, or if you want to host the Fermion platform by yourself, and just push it over and get the things running. So this complexity of a typical WASM procedure when I'm going to develop something, I need to build it, then I need to put the annotation, I need to move this image somewhere, then I need to find a platform which I can run it, and so on and so forth. This very long journey is just boiled down to hey, here you can get started with developing it. You can test it locally, and then you can push it somewhere. And it immediately fires up somewhere on either the Fermion Cloud platform, which is for some runtime for free, or you run the open source project of Fermion platform on your local machine or somewhere else, wherever you can put it in. You have to put some effort into this. You need some console and database and so on. But then you're good to go with playing around on this whole stuff. And this is something which we actually can have a short look at. Hope it's big enough. Sorry, it's not Gitpod. Next time. Actually, try to put it into the Gitpod. That's kind. I need to work a little bit on. So what you can see here is like a more or less typical Rust project. You have cargo for getting all the logistics done, and then you have here a very, very simple Rust application in the end, which just provides an HTTP endpoint, and then you build your application or your website in the end for bringing up a website. For sure, if you want to have a static page generator, it's maybe not the most convenient way to do it this way, but let's say for demonstration purpose, this is fine. So the first thing which we need to ensure is I'm logged in. So we need to wait for authorization. You get this code, you can jump over here. And then you can authorize. That's practically everything. This needs 1-2 seconds more until it recognizes that I'm authorized. And then we are logged in this case, to the Fermion Cloud. As I said, you can also do it with your local environment if you want to, but it's quite a lot of stuff. And as we have already an application, we can just say spin deploy. Oh, I'm not in the right one. And I need to go to the right window. Zack. It's immediately start deploying this application. It doesn't take that much time. Actually, theoretically, the website should be also already up and running. Yeah, ta-da. And this is actually quite nice and quite fast when you think about what's actually going to happen, because I write spin deploy, you immediately saw it popped up already, and I actually can also directly click on it. So for a Rust application, which is put into a WASM container, deploy to a cloud, and they spin up, this whole procedure is very, very fast. And when you play around with this environment a little bit more, even so when your application is getting quite huge, this process doesn't take longer than maybe a second. Maybe 2 if you have a lot of bullshit which you pull in, but as said, then the part is about the bullshit part, so you need to, anyhow, tidy up a little bit the application. And yeah, this is actually everything which I can fastly show you about Fermium because it's that simple. And this is actually what we see when we talk with customers also about it, what we would have expected in the past, especially when we talk about containers and all the procedures and processes around it. Because somehow everything moved in this field, but we have still this very long process of software development, and it takes always very long time until you get somewhere, and so on and so forth. And then, yeah, this is easy to integrate also for your procedures and processes for testing, and put it wherever you want to put it. The other thing which is quite nice, again, we go back to the WASM. I do not have so much stuff here in the WASM. The most relevant one is here the runtime class. Why? Because crun supports WASM out of the box meanwhile. So I even do not need to anymore install anything than like a WASM edge. This whole problem is gone for me. Perfect. I have here a cluster configuration. I will shortly run this. And then I have, yeah, kind of very stupid little pod. It's pulling an image which should run with something that we call WASM demo. Counted. Here you see the complete image, and you see the node selector. And this node selector is actually quite relevant for us. Because, and for this I need to shortly steal anything from here. I need to wait for this one. For this now, where's Gitpod? So if you do not know, it is Kubernetes in Docker. So it's just like spinning up Docker container and have a full Kubernetes cluster running into it. You may say like, nah, that doesn't sound so convenient. As someone who has like worked 3 years in Kubernetes release team, I can tell you, this is the only way how you're able to run more than 260 clusters simultaneously to test your current Kubernetes release. So Kind is a fully featured Kubernetes cluster with everything what you need. So first of all, we need to actually normally deploy our KWASM operator. The next step which you do is to deploy the operator to the cluster. There we go. We need to annotate, obviously, something with this KWASM node equals true. If you would not do this, then at this moment, Kubernetes would not know exactly, and also the operator would not know exactly where to throw the image. So you would get a failure out of it. Then last but not least, we need to ensure that we have the right runtime class. And then we can go and deploy the pod. So that's it. Overall, this is a little bit boring. You see at the moment it says continue creating. If you repeat this, oh, still creating. Maybe you got all the demo gods for your. That would be a pity. So we can, yeah, that's the thing. We ate all the pizza. So the first thing which we can check up is like, okay, do we have the one of the node labeled? Yes, it is. So it's not that it should not be able to find not the node. Maybe something in the log files. Failed to create pod things books. Oh yeah, something with crun. Perfect.
Yeah, just the runtime.
Yeah.
Not something for...
No. Okay, so my daemon gods are gone, but theoretically you would see that the container would like just shortly fires. Then you see a bunch of yada yada in the log files, and in the end it pops out like, hey, that's it, I'm done. Because the way how WebAssembly modules are working is not that it's continuously running, only when it has actively to do something. You can change this behavior, but it's a little bit tricky. If you have the need that your application is running 24/7 and doing some other stuff, or from the perspective of tech, of environmental sustainability, to waste on resources. Yeah, so far, that's about these two options. At least Fermion worked very well and smoothly, love it. So let's wrap it up. I often getting asked like from customers, okay, so thanks for being with us for years. Thanks for building 5 times Kubernetes clusters for us in every cloud provider and on-premise and on the edge. So we now throw everything out of the window and start by 0. The sales guy would say yes, but the truth is like, we will not replace containers. Containers have their, in German we say Daseinsberechtigung. They have their reason. I mean, there are some very nice words in English which are not translated from German, like Zeitgeist, right? Or Spiel. It's not translated. So yeah, maybe we need to work on implementing in the English language die Daseinsberechtigung. Sounds great. So we see it like this. Everything what comes with the containers and everything where they have to flow with containers, this will stay, obviously. And it will also keep evolving. And the ecosystem is so huge, so big, there is no reason to replace it. It maybe will get more efficient, inspired by WASM to say like, oh, we need to get more secure, we can get faster. But WASM is there for building some future platforms. Some, at the moment, smaller components running beside. I believe in the future, this will be something more like a kind of serverless way of thinking, living in Kubernetes, running WASM modules, and make this whole like, oh, I need to deploy somewhere my application very ridiculously easy. Just having a platform, drop it in, and really do not need to worry about anything else. So these both things comes together. It will live way beyond any kind of browser. It will also live in the browser, obviously. And I think the greatest chance, also if you are interested in this topic and make some research, is to go in this direction of developer tools and find out what's going on there. And if you're interested in contributing open source, this is a space which needs at the moment most of the help, because debugging WASM is like hell at the moment. And that's like where we will see like there's a lot of harmonization going on and tools needs to be grown up and thrown away and move along, like Krustlet. Awesome tool, awesome guys who have built it, first guys who have built it, but at the moment no one needs it anymore because suddenly Docker can do it, C-Run can do it, and so on and so forth. Yeah, and the number 2 WASM enables use cases that are not possible with container and Kubernetes. We see so often Kubernetes running on the edge, but how big is your edge? The smallest edge which I have found is sometimes as big as my smartphone, which sounds stupid because it's quite small, but it has a lot of power, a lot of possibilities to calculate. I mean, with your smartphone, you can fly to Mars, right? With your first Nokia handy, which you got, you could fly to the moon from the calculation power. So feel free to do so. But with WASM, because it's so ridiculously small and it doesn't need that much, you can really bring it to the edge, really on small devices, on cost-efficient devices, maybe on architectures which are not there yet, and it can be adapted to it. So WASM will be ubiquitous. Thank you very much.